I was reminded of a few things by a student that I don't think I made clear. One was standard form of a complex number. This is a term you might have run into in homework. And the standard form of a complex number is a plus bi, where a and b are real numbers. Now, what does that have to do with it? Well, if I gave you a number like, which I wouldn't, but if I gave you the square root of 3 plus 2i, that's going to be a complex number. If I gave you the number 4 plus 5i over 3, or 6 minus 7i divided by 5 plus 2i, these are all complex numbers, but they're not in standard form. Okay? Now, some of these are easy to put in standard form. Like this one could just be 4/3 plus 5/3 pi. And that's the A and that's the B. This one, we learned you can put in standard form by multiplying the top and bottom by the complex conjugate. That would be 5 minus 2i under 5 minus 2i. And then when you multiply the complex conjugate by itself, I'm sorry, a number by its complex conjugate, you always get a real number. You always get a positive real number, and it's a real easy number to figure out. It's just going to be, since it's 5 plus 2i, 5 minus 2i, it's just going to be 5 squared plus 2 squared, which in this case is 29. And from there, you know, after I FOIL this, I can break this up into the standard form. Okay, that was one thing I think I missed on Tuesday. The other is just a very, take care of this. The other is just kind of a subtle one. We saw that if you have a plus bi, that its complex conjugate is a minus bi. And this could look different if b is negative, right? It's a plus negative b. Well, if b is a negative number, then kind of this minus tends to it is. But the subtle point I missed was, what if b is 0? So I have a plus 0, and its complex conjugate is a minus 0. That's okay. You multiply them together, you get a squared. That's a real number. Nothing wrong with that. The same thing if in this situation, if a were 0. So that would be like 3i. Okay? That's 0 plus 3i. So its conjugate is 0 minus 3i. 3 times 3 is 9. I times I is minus 1. Oh, but this is a minus 3. So minus 9 times I, write that, minus 9 times I squared. Well, remember I squared, so I is the square root of negative 1. I squared is always minus 1. So minus 9 times minus 1 is 9. So that statement I made before, if you multiply a number by its complex conjugate, you will always get a positive real number. Here it's 9, here it's a squared, here it's 29. So, okay, I just wanted to go over that. A student came to me with some questions, and oh, I guess didn't make that clear. Any questions about that? Okay. So we've been working up to this section. This is -1 quadratic equation. And I guess I should add and formula. We've looked at problems like this before, or simplified problems like this before, but we were always able to solve them by simpler means. So, for example, here's a quadratic equation. And we look at that and we put this in its standard form. And then we said, oh, can we factor this? Well, it looks like maybe 8 and 3. And then I make 8 the plus and 3 the minus. Kind of doing backwards FOIL here. So I get x squared minus 24 minus 3x and plus 8x. 8 minus 3 is 5. So this tells me right away that x equals 3 or x equals minus 8. So we're able to solve this. We also, and I think I kind of jumped the gun on this, we talked about a way to do this for a slightly more difficult problem. X squared minus 4x minus 3 equals 0. The problem here is there's no way for me to factor this nicely like this one. I can try, and well, 3 and 1. Well, one of these has to be minus and one has to be plus. So there's no way to get -4 here. So instead, I talked about a different strategy called completing the square. Well, how does that work? Well, you have something like this. I don't do that example. And you take b and you perform this little kind of magic on it. You divide it by 2 and you square it. Well, if I'm going to add this, to keep the equation the same, I have to subtract it, of course. Now, why did I do that? Well, I know that this fits a certain pattern. If I FOIL x plus b over 2, the quantity squared, I'm going to get x squared, b squared over 2, and if you remember that pattern, a plus b squared, it's going to be x times b over 2 times 2 is going to be bx. So this quantity here is the piece that we're using to complete the square. I'll show you a real example in a second, but I just want you to see that I have x plus b squared, and now I've moved these two to the other side of the equation. I'm going to get b over 2 squared minus c, and now I can find the square root of both sides and find my two roots. All right, let me show you how we do this with this example. again, I look at b, you know, the coefficient of x. And I might add, this is only going to work if I have a 1 here as the coefficient. If I don't have a 1 here, I have some other number, I can divide it out because it's still going to be 0 on the other side. So I look at this coefficient here, it's minus 4. I divide it by 2, get minus 2. I square it, I get minus 2 squared. And that's what I use to complete the square. So that's 4. But then I have to subtract 4. Okay? This should be a perfect square now. X plus 2 squared. You might want to kind of check. X is x squared. 2 times 2 is 4. The inner is a 2x. The outer is, oh, excuse me. Good thing I checked. Since this is minus, this has to be minus, right? Sorry, now it's going to work. Minus 2x plus minus 2x is minus 4x. Okay. All right, what do I do now? Well, I've got minus 7 here. I'll add it to both sides. Now I'll find the square root of both sides. And again, this is that one circumstance where we know to get 7, it could either be the square root of 7 or negative square root of 7. Once my negative square root of 7 times itself, I still get 7. So now I have x minus 2 equals plus or minus square root of 7, or x equals 2 plus or minus square root of 7. So this is completing the square. I'm going to show you an application of it here. We don't use it that much in, well, we won't use it much in this class. There's a particular subject where we used to use it a lot. Like give you an equation, I guess I'll put it over here. It looked like this, it's x squared plus 2x plus y squared plus 4y minus 8 equals 0. I say, well, what's this the equation of? And it wouldn't be obvious, but we would apply this technique. We could say, okay, x squared plus 2x plus 1, that's 2 divided by 2, squared is 1, plus y squared plus 4y plus 4, again, 4 divided by 2 is 2, squared is 4. We're going to move 8 to the other side, and since we're adding 1 and 4 here, add 1 and 4 here. And now we have x plus 1 squared plus y plus 2 squared equals 12, 13. And now, if we were in that class, you'd recognize this. You'd go, I know what that is, because I know that the equation of the circle is x minus a squared plus y minus b squared equals r squared. So this is the equation of the circle that's kind of offset from the origin with radius square root of 13. We used to do that a lot. And it will come up again in pre-calc. It'll come up in calculus if you get that far. So it's a good technique to know. completing the square. What we're going to do with completing the square, I think I did it, I may have done it before, but I think it bears repeating, just to see it done. We're going to solve the quadratic equation. That I mean, very general ax squared plus bx plus c equals 0. That is, any equation with any a, b, and c, we're going to find a formula that will give me its roots, or its solution, or its zeros. We're going to do it the same way we've done these. It just looks more complicated because I'm using abstract constants, a, b, and c, numbers. So my first step, again, would you just sit back and enjoy this? You're not going to need to repeat this on an exam. Just kind of watch the magic happen, because you already know where we're going. You've all seen it before. First thing I want to do is I want to get rid of this a here, because when I complete the square, as I said, this has to be 1. So I'm going to divide everything by a. And I'm going to get x squared plus b over a x plus c over a equals 0. That's my first step. Now it kind of looks like that problem I just did. Now I want to complete the square. So I say x squared plus b over ax. Okay, now here's the hard part. I divide this by 2, and I square it. Well, divided by 2 is b over 2a. Squared is the square. Now I'm going to subtract ca from both sides. I'm going to squeeze in 2 steps. And now I have to add this to both sides of the equation. Or I can subtract it, but it turns out the same. Okay, so this is like a little complicated. Just try and follow me, go with the flow here. You're going to end up somewhere you're going to be happy about. I completed the square here, so I know that this is a perfect square. It's x plus b over 2a squared. If I FOIL this, x squared here, b over 2a squared here, 2 times x times b over 2a is just b over ax. So that worked. I think I'm going to go ahead and apply the 2 here, b squared over 4a squared. And I might as well put it over a common denominator. So to do that, I have to multiply the top and bottom by 4a. Now what I want to do is the same thing I did when I was solving my other problem.
Professor, I have a question.
Oh, sure.
When you put the b over 2a on the other side, is that a positive, like go up one? See that, when you put it on the other side, is that supposed to be a negative or a positive?
It's always positive.
On the other side, see where the minus ca is that b over 2a, that's supposed to be positive or minus?
This one,
Yes.
since I'm adding it to both sides of the equal sign, I add the same thing.
Okay.
So they should both be positive.
Okay.
If I do it like this, then it's negative, because it's on this side of the equation. Did I make that more confusing?
Okay.
Okay. All right. I'm going to find the square root of both sides. And as in the other example, this is just a number. It could be positive or negative. All right. Let's take this over here. finding the square root of something squared, that's just going to be x plus b over 2a. And that's going to equal plus or minus, I'm going to split this now, square root of, because I already have it over a common denominator, b squared minus 4ac over the square root of 4a squared. All right? And now to solve for x, I'm going to subtract b over 2a from both sides. So x is now negative b over 2a plus or minus square root of b squared minus 4ac. Well, the square root of 2a squared, that's just 2a, right? Well, so I already have a common denominator here. All right, so the way we usually see this is what we call the quadratic formula. I think all of you have seen this before. You may have had a little trouble memorizing it, but maybe seeing where it came from will help, maybe not. Plus or minus square root of b squared minus 4ac all over 2a. These x's, if I plug them in here, will be equal to 0. It's like, if you can remember this, you don't really have to know how to factor. You don't have to know how to do completing the square. It's kind of like an all-in-one solution. You might ask, well, why do we learn that factor? Well, it's easier. We learn how to complete the square. Sometimes you can't use this, like in my example with the circle. But all right. So I'm going to transfer this over here. Does anyone need me to hold off erasing the board for a minute? You don't need to be able to reproduce this. It's all within, I didn't want to say it, it's all within your grasp, you can understand. It's just algebra. It's just what we've been doing, manipulating polynomials, finding radicals, square roots. There's nothing particularly, it's a lot of steps, but it's nothing outside of what you can do here. All right. So I guess I'm going to rearrange this. So the quadratic equation, or the general form of it, is ax squared plus bx plus c equals 0. And the quadratic formula that gives us the two solutions, or the two roots, is x equals negative b plus or minus b squared minus 4ac all over 2a. Okay. This will carry us a long way. Few comments. This plus or minus is where we get two roots from, right? We evaluate it with plus and we evaluate it with minus. There's something interesting about that we're going to get to in just a second. But first, I want to draw your attention to this piece here, or actually what's inside the radical. B squared minus 4ac. This has a special name. This is called the discriminant. It discriminates between three cases that we're interested in. Now, if b squared minus 4ac is greater than 0, Well, the square root of a positive number is some positive number. Maybe an ugly square root, may not. But we have a positive number, plus or minus positive number, divided by a positive number. We get two roots, two real roots. Talk about this case. Two real roots. I suppose we should have an example. Just an example. Well, problem we started with, x squared minus 4x minus 3 equals 0. Let's just do this. So negative b, that's the negative 4, negative 4. 4 plus or minus the square root of b squared, 16, minus 4 times this coefficient 1, this coefficient negative 3. So 4 times 1 times negative 3 is negative 12. No. Yes, okay. So plus 12. All over, 2a is 1, so just so let's look at this. That's 4 plus or minus 28 over 2. And 28 is 4 times 7 over 2, which is square root of 4 times the square root of 7, which is 4 plus or minus 2 times the square root of 7 over 2, so it's 2 plus or minus the square root of 7. I hope that's what we got the first time. All right, so that's an example where the discriminant is greater than 0. The discriminant could be 0. Let's look at an example of that. Again, 4 plus or minus the square root of negative 4 squared, 16, minus 4 times a times c, that's 16, all over 2, that's 4 over 2 plus or minus 0, this is 2. Okay, we just get one root. If I were to factor this, you'd see x minus 4 times x minus 4. It's kind of like we have two roots, but they're the same number. So that's the second case. And thinking about it, of course, there's going to be a third case. This third case is the whole reason on Tuesday we spent all that time talking about imaginary complex numbers. Let's try an example here. Yes. I think if I do this, I'll get what I'm looking for. All right, 4 plus or minus the square root of 16 minus 4ac, right? That's 24 over 2. That's 4 plus or minus 16 minus 24, that's negative 8 over 2. It's 4 plus or minus square root of 4 times the square root of 2 times the square root of negative 1 over 2. Well, that's going to be what? 2 plus or minus, well, that 2 is, yeah, I divided that. I'm not doing this very nicely. I'm going to write it all out. 4 over 2 plus or minus square root of 4, that's 2, square root of 2 times 5 over 2. And you can see here that's 2 plus or minus square root of 2i. All right. Here we have two complex, or, you know, just plain imaginary roots. That's why we call this the discriminant. If you look at that number, b squared minus 4ac, you can check right away what kind of results you're going to get. Now, there's something special about these two roots. I'm going to write them out. 2 plus square root of 2i, and 2 minus square root of 2i. Does anyone tell me these have some kind of relationship we've talked about? Does anyone recognize it? We talked about this on Tuesday. These are complex conjugates. You will always get the two roots. If you have complex roots, they will always be complex conjugates. That means if we multiply these together, we're going to get a real number. Okay. Okay, there's one more thing I want you to know about these three cases. Does anyone remember what the graph of a quadratic equation looks like? Yes?
Is it like this?
It's a parabola, yes. It could be like this, kind of holding water, or it could be upside down. Now, if the parabola goes through these 2 points, that's where y equals 0. That's like the solution of this kind of equation, right? This is a big jump here. We're going from the equation to the picture. The same thing is true here. Does anyone know how you can tell right away whether it's going to be shaped this way or shaped this way? Okay, we don't have a lot of time for this. If A is positive, think a lot. A is negative, it's going to be down. Okay. If the discriminant is greater than 0, it's going to cross the x-axis this way. You're going to get two roots. The other two possibilities, you're going to get something different. In the case where b squared minus 4ac is 0, what's going to happen is parabolas, even though I'm not drawing it that way, it's symmetric. And there'll just be one point on the y-axis. I mean, but one point on the x-axis where y equals 0. That's this case. And in the third case, where you have imaginary roots, but we can't possibly cross the axis. And if you graph it, your parabola either will be above, going up, or it'll be below, going down. Class always goes so fast, and I don't really have time to show you this in more detail, but I guess maybe we could talk about this next Tuesday a little bit. All right. Are there any questions about this? The homework may kind of exercise your brains a little more on this. Definitely bring in questions on Tuesday.